Okay, good morning, everybody. So I'm going to try to capture today. I'm going to try to use this instead of the board because it captures everything as part of the lecture. But we're talking in chapter 8, I believe. We're talking about sampling distributions, and we've talked about two different distributions at this point. The first distribution we talked about is when we are sampling and figuring out the sample mean, okay? We're figuring out X bar. And we realized that there's a formula we use. You guys can't see that, can you? I get a mark. There's a formula we use to convert X bars to Z values to standardize them. It looks like this. And what was this is a kind of review of the previous class, before the last class. What formula did we use, or what theorem allowed us to use this formula? What theorem was the theorem that allowed us to use this formula? Just to review. It was the central limit theorem, and the CLT, the central limit theorem, has three components. The first one is that the mean stays the same. The second one is that the variance of the sampling distribution is equal to the original variance divided by n, or, because these two things are related, the standard deviation is equal to the original standard deviation divided by the square root of n. And the third thing is that if I sample enough, the distribution becomes normal. So this allowed us to use this formula because if you recall, the mean stayed the same, so we didn't change, and the standard deviation went from this to this. So that is kind of the foundation that allowed us to apply that formula. What we learned last class, though, is that not all data is interval, and only we can calculate out means for interval data. So a lot of times data is nominal or ordinal, and if so, what is the measure we use to describe data that is nominal or ordinal? What is one of the measures that we primarily use? If I wanted to explain, I think, the gender mix in this class, or the major mix in this class, or the student-athlete mix in this class, I would use, Alexis? It's nominal data, right? And what measure would I use to explain, like, what the mix is? What's that? Well, interval is like real data. Jonathan?
Proportion?
Sure, yeah, it's a proportion. Like I would say this class is 80% student athletes or 20% male or whatever it might be. So we learned that we can also look at the sampling distribution of a proportion. And we said, hey, p hat is the sample proportion. And we learned that p is a population proportion. Population proportion. And the formula that we were able to use, once again, to get us to a z value, which we know everything there is to know about, look like this. Z is equal to p hat minus p divided by the square root of p times 1 minus p divided by n, where n is the sample size. And I gave you some examples of when we might use this, and specifically we talked about quality control, auditing, where we say this is what we think the population is. Can we go out and see if there's evidence that kind of makes it look dubious? And that's kind of what we did. So this is what our homework was based on. Z is equal to p hat minus p. So let's look at, I gave you 4, I believe, and I think I told you, maybe I told the 11 o'clock class, 18, 19, 21, and 25. And I said, I'd like you to do 2 of the 4. You choose, and it's all by hand. So are there 2 that you would like to do? Or I'll just pick 1 and do it. So is there 1 that you would like to do? Is there a request? Or should I just choose 1? Sid? Sure. So let's look at 25. So the Red Lobster restaurant chain regularly surveys its customers. On the basis of these surveys, the management of the chain claims that 75% of its customers rate the food as excellent. I haven't eaten at Red Lobster in a long time. You guys eaten there lately? Yeah, no, they're owned by the Darden Group, who also owns Olive Garden. Yeah, I haven't eaten at the Olive Garden in a long time either. Have you guys? Breadsticks, yeah, never-ending breadsticks. I guess I know a waitress that works for Red Lobster. And you know what her most unhappy time of the year is? Like really unhappy. What do you think? I guess they have like this endless shrimp promotion. And yeah, it's apparently packed, and apparently the people that the kind of people that come in for endless shrimp are like not good people. Like they're greedy type people, and they don't tip well, and they're mean, and they want like thousands of pounds of shrimp, and they don't tip you well. So she absolutely hates endless shrimp. So anyways, all right. A consumer testing service wants to examine this claim by asking 460 customers to rate the food. What is the probability that less than 30% rate the food as excellent? So a consumer testing service. Let's talk about that term before we get into the problem. Give me an example of a consumer testing service. Anyone ever? What's a good consumer testing service? What's the most popular one? What's that? SurveyMonkey. SurveyMonkey is just the online survey tool. But a consumer testing service, like if you were going to make a big purchase, like a car, a refrigerator, I don't know what the hell else you make, big, TV, who might we go to first? Yes, sir. Yeah, you guys ever hear Consumer Reports? Okay, Consumer Reports, I subscribe because that's the way I am. They use data, and they can't look at every damn car that's on production, right? So what do? What they do is they use their readers as a survey, and they say, you own a 2015 Subaru Forester. Have you had any problems with the engine? What would you rate this car? And they use a sample. They publish those results, and then people make inferences about, hey, that's a reliable car, that's a crap car, right? Do you guys ever see that? They are using what we're using here. They're using samples. They wreck cars, right? They can't wreck every damn car. They wreck a sample of cars and say, how did they hold up? Do you understand what I'm saying? So that's sampling at its best. But there's also places that do testing of all kinds of things, but Red Lobster is one. So let's look at the data that we have in here and try to do the problem. So first thing it says 75% of its customers rate the food as excellent. What is that? As a term, what is that? Is that P? Is that P hat, or is that N? 75% is what they think people rate as excellent. Is that P hat, or N? It's P because it's the population proportion. So they claim that 75% rate their restaurant as excellent. So to try to see if there's any truth to that, we wanted to go out and we sample 460. Oops, 460, I forgot the 6. What is the odds that sample comes out to be less than 70%? So if it truly is 75%, we sample 460, what's the odds that it comes out to be less than 70? Well, I need to convert that p hat to a z-value using the formula that I just showed. P times 1 minus p divided by n. So I'm going to do that. P, whoops, you guys can't see that, is the probability that z is less than, let's see, 0.70 minus 0.75 times the square root of 0.75, 1 minus 0.75 divided by n, which is 460. So the denominator, or the numerator, is pretty easy. It's negative 0.05. And the denominator, I need to do a little work. Okay, so let's see if this works. I'll try to do this. I'll say we take 0.75 times, 1 minus 0.75 is 0.25. Okay, divided by 460. Okay, and then I take the whole square root of that. And I get a denominator of 0.022, we'll say, 0.0202. Okay, so let's do the math there. 0.05 divided by 0.0202 gives me the probability that z is less than negative 2.48. Okay. So we need to look that up in our z table. It's less than, which is great, so all I have to do is a standard lookup. Negative 2.4.8 gives me 0.0066. So that is the odds that that should happen. That if the true popularity is 75%, that if I sample 460, that it comes out to be less than 70. So let's say I did sample 460 and it came out to be 69.9%. It says the odds that that happens is this. So once again, and I know this is probably getting boring, but what does that kind of lead us to believe? Anything? Brad? Yeah, that, you know, there's a chance that if it truly is 75%, that I sample 460 and I get less than 70, but it's unlikely. It's very unlikely. So that makes me think either something was wrong with my sampling, or maybe that original claim was inflated as well. And there's a lot of that kind of stuff. I mean, you know, there's a form of BSing that is relying on statistics, right? Because people tend to believe numbers more so than like words. They say, oh, that's exact, that's precise. So, you know, you see a lot of that in a lot of the advertising world. You see those kinds of things. By the way, thinking of sampling, you know, this is a consumer area, and what could be the issue with this is they think that 75% think the restaurant is excellent, but typically how do restaurants take surveys of their consumers? That's a way that they do. Yeah, so
like a DM whenever they ask, like on your receipts.
Yeah, so they do
website and do it from there.
Yeah, very good. There's receipts. There's also like the little comment cards. You know, maybe Haas's used to do that. I don't know if they do anymore. But what happens in those cases? Who's filling those out? I think, you know, Jonathan.
People that are mad.
Yeah. So really, it's probably actually a bipolar, right? It's probably people that are very unhappy, who had a crappy service, crappy meal, or people that are very, very happy. And quite frankly as well, how about the demographic of those people? Not just the experience, but what do you think about the demographics of the people? So I roll in the Red Lobster. I have 5 children, right? So I'm just trying to survive that meal, right? You know, I'm trying to, you know, just get through it. Do you think I'm likely to fill out a survey whether I had a decent experience? No, I'm not, right? But maybe if it's, you know, I'm 70 now and me and my wife are there, and I'm like, oh, chance to make $1, you know, I'm like, oh, what the hell, I got time, I'm retired. You know, I may fill that out. So their number may be inflated because of the way that they did it, you know, and maybe the consumer advocacy took a more unbiased sample, right? So you always got to be aware of that. So that's it. That concludes. Any other questions on the homework? You guys can do that. So the first exam we'll have, which will probably be week 4, probably, I'm thinking like Tuesday of not next week, but the week after, we'll probably be ready for an exam. There'll be 2 manual problems. One will be like this, and one will be like the central limit theorem that we did. You guys remember? Yes. Okay. All right, so we are then going to move on. What are you guys putting that in your planners already?
I'm just making sure that's
What day? What is that day?
31st.
That sounds good. End the month on a good note, right? Okay, so we started last class talking about estimation. Estimation, as you guys know, there's 2 forms of inferential statistics. They are estimation and hypothesis testing. The first thing we're going to cover is estimation. And in estimation, what we're trying to do is we're trying to take a sample statistic and make an inference about a population parameter. Remember, that's what statistical inference is all about. We take data, we apply statistics, and we try to get information, and we're trying to take a sample statistic and make an inference about a population parameter. The 2 that we're going to focus on first is we're going to use the sample mean to estimate the population mean, and we're going to use the sample proportion to estimate P, the population proportion. Those are the 2 things that we'll do before our first exam, okay? So before we get into the methods, we wanted to talk a little bit about what estimation is, and I gave you some terms. And there are two types of estimators, a point estimator and an interval estimator. A point is one number, an interval is a range. We talked about that last class. Why in the world of statistics don't we use point estimators? We start with them, but why don't we use them?
They're not very accurate.
Too narrow, you're right, they're not accurate. What's the odds that it is exactly right? Zero, virtually 0%, because when you ask my weight, what's the odds that I'm exactly 200.000 pounds? Virtually zero. So what we tend to use is interval estimators, okay? Because we can control things, and a range, is fine. We can say there's a 95% probability that it's in there. We talk about that as certainty. So what we're going to use in our class is we're going to use interval estimates. We're going to say like the mean income is between 380 and 420. What do we call the low and what do we call the high? And I defined that last class when we talked about weight, my weight estimate. What do we call the low? What do we call the high? Yes, sir.
LCL?
Yeah, the low is called the LCL, which stands for lower confidence limit. And the high is called the UCL, which stands for upper confidence limit. What do we call the whole range? Do you guys remember what we called the whole range? From the low to the high. Also had that same word in confidence. Go ahead. It's called the confidence interval, right? The confidence interval. So those were some terms that we had. The other thing that goes along with that, all right? So we have a range, but we want to talk about how confident. You hear this word confident all the time. We want to talk about how confident we are that the true value, that thing we're estimating, is in that range. What do we call that? What do we call that thing? What did I call that? The certainty I am that my true value is in that range. What did I call that? You guys remember? I said it had to be at least, in the world statistic, it has to be at least 90%. What do we call that? Kira? Yeah, confidence level. Confidence level, and I didn't show you this earlier, but the confidence level, the symbol we use for confidence level is 1 minus alpha, okay? And confidence level has to be 90% plus, okay, in the world statistics, 90% plus. So, those were some terms that we had. Some things that I didn't cover, okay, is qualities of estimators. Estimators need to be, the first two are important, okay? Estimators need to be unbiased and they need to be consistent. If I use, I don't know, your height to estimate how well you're going to do in this class, I would say that's kind of a biased estimator, right? I don't think that is going, there's no reason that should be. If I use the sample mean to make an inference about a population mean, I think that's probably a pretty unbiased estimator. So estimators should be unbiased. An unbiased estimator of a population parameter is an estimator whose expected value is equal to that parameter, meaning if I sample an infinite amount, it's going to equal that thing I'm trying to estimate. Secondly, it should be consistent in that the more that I sample, the sample size grows larger, it gets closer and closer to that value, okay? And I don't need you to worry about the second one because we're not going to really, or the third one, because we're not really going to compare those things. All right, so let's leave that alone. All right. Your book, you guys remember when we talked about your book? I started using a few years ago this book, which is a magazine, they call it a magazine type of text. They're a lot cheaper than, I think if you get the traditional text for this class, it's like $300. This was like, I don't know what it was, but anyways, they take out some material out of it, right? Because it's a magazine text. So the first part of this section, we are going to use a PDF that I created. It's not in the book, but we're going to use this PDF that's at the top of chapter 9. It's called Estimation of the Mean Material. And all I want to pull out of here at this point is the formula that we're going to use. Okay, the formula that we're going to use to estimate the population mean. So we're going to use the sample mean. Whoops. We're going to use the sample mean, which is x bar, to estimate the population mean mu. And this is the formula we're going to use. And some of these things in this formula you'll know, and some of these things you will not know. So we're going to use the sample mean to make an inference about the population mean. There's the formula. Give me something you know in that formula. You say something, Nick? You say something? Well, say it more confidently this time. What's x bar, Nick? What is x bar? Very good. X bar is the sample mean. So how would I get the sample mean? If I sampled 100 people, I'd add up those 100 people, whatever the responses were, divide by 100, that's the sample mean. Very good. So we know this is the sample mean. We've seen that before. Sample average, x bar. What else do you know? What else do you know in that formula? We know what x bar is. We know that's the sample mean. That's kind of our starting point, if you will. What else do we know in that formula? Kira? Okay, very good. This is the population standard deviation, which we've seen before, right? That's the population standard deviation. What else is familiar to you in that formula? There should be one other thing that's very familiar to you. Max? N is what, Max? The sample size. So if I sample 10, there's that N is 10. If I sample 1,000, N is 1,000. Anything else in there? Anything else in there? Higher. Z. Okay, we've seen Z before. Have we ever seen this before, though? Alpha sub 2. We've seen Z before. We know that's the standard normal curve, but we've never seen Z sub alpha divided by 2. Let me show you where that comes from. Okay, well, before we do that, how about the plus minus? What do you think the plus slash minus is? Brad, what do you think that is?
I was going to ask the Z.
Yeah.
What are the, is
that
2?
No, I'm sorry, that's a bad alpha.
That's that. Okay.
That's alpha. You know what alpha is? Yes.
Yeah, and it's divided by alpha 2. Or?
Yeah, this is Z sub alpha divided by 2.
Oh.
You know what alpha is? It's like the Jesus fish. You know, that's a terror. Let me make it nice one. That's as good as I can do. That's alpha. Okay? So this is alpha divided by 2. Huh?
It's a breast cancer sign, just twisted.
Yeah, that's what it is, yeah. Kind of. They use that for everything though, not just breast cancer now. That pin is like, that symbol is like I support whatever. But the pink one, yeah. Plus minus, how about plus minus? Plus slash minus means what? Okay, so think about what we're estimating. What kind of estimate did we say we're going to use? A point or an interval? So why do you think we have plus minus there? Because what we're going to do is we're going to start with our point estimate, which is x bar, and one time we're going to subtract everything on this side, and guess what that gives me? The LCL, and the one time I'm going to add everything on this side, and that's going to give me the UCL, right? So it's really, this formula gives us two terms, the low and the high. That's what the plus minus means. So let's get back to this Z sub alpha divided by 2, okay? So here's where this comes from. Think about confidence level. So confidence level, I'm saying, is 1 minus alpha. And I said the minimum confidence level I'm willing to accept is 90%. So let's think about that. I need to make sure that 1 minus alpha, we're saying, is 90%. That's the confidence level, yes? So if you think about it, I want to be 90% confident, okay, 90% confident that my true population parameter is in this range. Whatever this LCL is, that would be the LCL, and that's the UCL, right? I want to be 90% confidence in there. Well, think about where this comes from. That's the z-curve. If 1 minus alpha is 90%, well, okay, if this is 90% and these two are equal, what are each of these? Tails. Go ahead. If this is 90%, we know the whole damn thing is, so what's left over? 10% divided by 2, 5% over here, 5% over here, right? So 1 minus alpha is 90%. Let's think about it. That means alpha is equal to 10%. That means alpha divided by 2 is equal to 5%. So what this is saying, okay, follow me. If we're using a confidence level of 90%, that means we're looking for the z value. You know, alpha is 10%, alpha divided by 2 is 5%. We're looking for the z value that has area to the right. That's what this means, the sum. The z value that has area to the right equal to 5%. Is that what I'm saying? So confidence level we use is directly related to what we plug in here. So let's look at that. What z value would have 5% to the right? What z value would have 5% to the right? And we're not going to have to do this, but I'm going to do this one time. If I'm looking for a z value that has 5% to the right, and remember this is cumulative probability, how do I want to find that in this table? So if it has 5% to the right, what does it have to the left? Courtney? 95%. The cumulative probability is 95%. So let's go in here. This is where the area is. What's the closest to 95%? Well, it looks like we have 0.9495 and 0.9505. And that translates on the outside to 1.64 and 1.65. So one's a little high, one's a little low. Let's go between those, and we get 1.645. Okay, so 1.645 is the z value that has 5% to the right, and negative 1.645 is the z value that has 5% to the left. Which is kind of a pain in the butt, what I just went through, right? To do a reverse lookup on 95%. And we're always not dealing with 90% confidence. Sometimes we're dealing with 95%, 98%, 99%, and I'd have to do the same thing. But if you think about it, what happens is there's really only 4 confidence levels that are typically used. Oh, you guys can't see this. There's only 4 confidence levels that are typically used. 90%, 95%, 98%, and 99%. So if we're using 90% confidence, all we're going to do is plug that value in for z sub alpha divided by 2. If we're using 95% confidence, we're going to plug in this value. If we use 98, if we don't do that much, we're going to use this value. If we use 99, we're going to plug in this value. And these numbers, you know, you'll do this so much that you'll just know, hey, 90% confidence, 1.645. 95% is 1.96. You'll see that, okay? But I don't expect you to memorize that. So this little table that I'm referencing up here, you'll be given that, right? So you can use that table. You say 90% confidence, that means, hey, 1.645. Does this make sense? Okay. So let's go back to the formula. Because I want to come back to something that we talked about, you know, when we were estimating my weight. What happens if I look at this formula, and remember, this thing, this term over here, controls how much I add and how much I subtract. You know, it's always going to be the same. So plus 5 minus 5, plus 7 minus 7. What happens to that range if I sample more? If I sample more, n gets bigger, right? And n's in the denominator. So what happens to this term when n gets big? When n goes from 25 to 1,000. When I divide by a bigger number, what happens? It gets smaller. And that's what we learned, right? Like mathematically, it looks like it's true, but if n goes up, the confidence interval goes down, right? As n goes up, the confidence interval goes down. It makes sense. The more I know, the more precise I can guess something. Yes? Yes. Okay. How about this confidence level? Remember we said, when I made you guess my weight and be 99% certain, what did you do? Did you make that range smaller or bigger? And I said, you need to be 99% certain. Did you expand your range or did you decrease your range? You expanded it. And think about it. What we're doing is the confidence level leads us to plug in what the z sub alpha divided by 2. 90% confidence, we plug in 1.645, which is smaller, 99% confident, 2.575. So what we learned, and what we can see in the formula itself, is that if nothing else changes, if we increase the confidence level, meaning I have to be more confident and I have no new information, that confidence interval is going to get bigger as well. Now, this is an easy formula to apply, but that's what's so great about it. It is so powerful. You don't know something about, what's the average sell at, this convenience store. Maybe you don't have access to all the transactions. You can sample 500-600 transactions and get a pretty accurate estimate. How many hours of TV does the average 46-year-old watch? Well, you don't have to talk to every 46-year-old in the United States. You can sample some 46-year-olds and get pretty damn precise. What is the average amount of St. Francis University student loan? Well, you have to talk to every St. Francis alumni. You can talk to some and use this to get pretty damn close. Okay? So I'm going to give you one. I'm going to make up one. Let's say this, and then we'll do some other things with this. Let's say this. How many? There's let's say there's 36 of you in here, right? So let's say I sample you 36 students, and I ask you how many hours you slept last night, right? And let's say I added up. What do you guys sleep? What do you sleep about, Steph? 9, nice. You always look good, that's why. Is he an outlier? What do you sleep, John? 6? So what would you say? It'd come out to about a 7.5, you'd say? Do you guys get that much?
Well, during the day after class, yeah. Naps.
Oh, I'm counting, night sleep, not naps.
Then 6.
Naps go away when you're 40, by the way. Let's say 7.5. So I added up, I sampled you guys all, which we're going to do actually, but let's say it comes out to 7.5 hours, okay? And I want to know with 90% confidence the average hours that a St. Francis University student sleeps, okay? So this is all the information you need. We could have gathered that quite easily. I don't want to sample everyone, but we're going to online. And calculate out these things. So this is the formula I want you to use. And I want you to estimate the average number of hours slept by St. Francis University students with 90% confidence. Now you may need to use, and you do need to use actually, this table. So 90% confidence means z sub alpha divided by 2 is what? 1.645. So I'll write that down for you as well. So let's do it. Or you do it. What didn't I tell you that you need? Let's just make it easy. Let's say standard deviation. What we have? We had Stefan with 9 and someone with like 6. Let's just say it's. Let's just assume it to be 1. Just make the math easier. Probably higher than that, but let's just do it as 1. All right, so we wanted to figure out the average number of hours slept by St. Francis University students. We used you guys as a sample, not really, but we said we did. And we said, all right, let's see, 7.5 hours would be the point estimate, but we are statisticians, so we're going to use an interval estimate. The confidence level is 90%. That means Z sub alpha divided by 2 is 1.645. Standard deviation I gave you is 1. And we said we sampled 36. So square root of 36 is 6. 1 divided by 6 is 0.16667 times 1.645, which is my Z sub alpha divided by 2. And I get 7.5 plus or minus 0.27 hours, okay? So this is called my confidence interval. 7.5 plus or minus 2.7. And you've probably seen that displayed that way before, right? When a lot of times when you see like, margin of error, right? You see margin of error, like this political poll says this candidate is at 38% plus or minus 5%. That margin of error is that, that plus or minus. If I wanted the LCL and UCL, which I do, how do I find those two things? How would I get the LCL and how would I get the UCL? What do you think? The LCL is the low and the UCL is the high, Max.
You just take 7.5 and then for the LCL minus 0.27 and then for the UCL you do plus.
Okay. So what I want to show you, and this is kind of a little fabricated example since I made up standard deviation, I made up the mean, and I made up the fact that I took a sample. However, if you think about it, I had no clue about how many hours you guys slept, right? On average. No clue what that population mean is, what mu is. I don't know what it is for St. Francis University students. Just by sampling 36 people, or pretending to sample 36 people, I'm 90% confident, which isn't bad, that population mean is in this range. 7.23 to 7.77. Now, I have some knowledge where I didn't have knowledge before. Couple things. If I want to be more confident, I said, 90% is no good. I want to be even more confident. I want to be 99% confident. What happens? What changes? Still did the same sample, still got the same results, but I want to be 99% confident. What happens in the formula? What changes? What changes? Come on, if I change the confidence level, what changes? Brad? The Z sub alpha divided by 2, right? and it goes from 1.645 to 2.575. It gets bigger, so what's going to happen to my confidence interval? It's going to get wider, right? I increase the confidence level. That's what I said. The confidence interval goes up. Now, let's say this. Let's say I wasn't happy with this, and I want it to be even smaller. I really want to zero in on the true population mean of hours slept. I'm not happy with a range of plus or minus 4.27. I want to be more precise. What could I do? What could I do to be more precise? Yes, Matt.
You could lower the cost.
Well, normally I could, right? But I'm at 90% in the world statistics, remember, we don't go lower than 90%. If it was 99%, you're right, I could lower it to 90. That would reduce the confidence interval. So because I'm already at the lowest I'm willing to work with, Max, there's only one choice that I can do. Sample more, right? We increase the sample size. Think about it. This end goes from 36, let's say, to 100. Now we're multiplying by not 1/6, we're multiplying by 1/10. To reduce that, and we're going to zero in. So remember that central limit theorem, coming back to that? What it showed is, think about it, we rolled 25 die. Boy, that thing really tightened up, right? The more we sample, the more it tightens up. And that's why we're able to say with the same confidence level, an even thinner interval. That's the beautiful thing about about estimation and about the central limit theorem. Here's what I'd like you guys to do. One more. This isn't going to be a fabricated one. Then we're going to do a little survey, and we're going to bust this out with Excel. Let's do in this PDF that I have. I want you guys, it's on chapter 8, it's very top, it says estimation of the mean material. And on 337 of that PDF, there's not that many pages, right? I want you to do number 26. Do number 26. So we're trying to know the amount of time that it takes to change oil on a car. Okay, change oil on a car. The average amount of time it takes to change oil. Man, I hate when I'm hungry at 10:14. That's not good. Sometimes even though I want to think of now what I do. I mean, I like Torbjorn's food, but I eat too much there because I just do. I like the salad bar a lot. I'm a big salad bar fan. But I don't make healthy salads. I make like 2,000 calorie salads. So it gives you the standard deviation, right, that's 5, and it gives you the confidence level, which is going to translate to z sub alpha divided by 2. But it doesn't give you x bar, so how do I get x bar? I see some people like confused. Where does x bar come from? It doesn't give you that. How do I get x bar? It's the mean, so what do I do? What would you do? Yeah, there's 10 of these, so add them all up, divide by 10. That's your sample mean. That's the sample. How do you get a sample mean? You average it. You average a sample. That's what a sample mean is.
You break that amount up,
It's 2.575. 2.575 for z sub alpha divided by 2 for 99%. Okay, so we want to use this formula to estimate the mean average amount of time it takes people to change oil. So to that end, it told us, hey, the population standard deviation of oil changes is 5 minutes. That was a given. It told us that we sampled 10 people, so n is equal to 10. To get the sample mean, I need to add up all those samples, divide by how many there are. There are 10. What did you guys get for that value? I didn't do the math. Someone? 16.9 minutes. So 16.9, that would be the point estimate. It says 1 minus alpha is 99%. That's the confidence level, so it's 2.575. So we have all the information we need. It's just a matter of plugging and chugging here. 16.9 plus or minus 2.575, 5 divided by the square root of 10. So I'm going to do all that on my calculator. I'm going to get, let's see, 5 divided by 10 square root times 2.575. It's 16.9. I'm going to make it easy. 16.9 plus or minus 4.1. Okay, 16.9 plus or minus 4.1. That means the LCL and the UCL are this. The LCL is 15.8 and the UCL is 21.0, I believe. Okay, if I add and subtract. It's not. It's 12.8, right? Okay. So let's see you're doing this for your boss, and she says, thank you for doing that. Now I know it's somewhere, I'm 99% confident that the average time it takes someone to change oil is somewhere between 12.8 and 21 minutes, which is good. That's better information than I had before. But she says, it's not as useful. I'd like you to get it more precise. She wants you to diminish the confidence interval. You tell her there are 2 choices for me to do that. What are the 2 choices for you to do that? Kira? Very good. I can give you a tighter range, but I'm going to be less confident in that range, right? Go to 90%, this becomes 1.645. Because I'm multiplying by a smaller number, I'm going to get a smaller interval. Very good. The other thing is, she says, no. I still want you to be 99% confident. Certainly I can do that. What could I do then, Max? I increase the sample size from 10 to 100. You think about this, it's going to make it a lot tighter. Make sense? Now, a lot of times when we do estimation, obviously, we're not just dealing with sample sizes of 10, we're dealing with sample sizes of hundreds. So we are typically going to use Excel. And if I go to Blackboard under Chapter 9, there is a template that we're going to use to kind of put in information, but we're going to have to come up with the information based on stuff we learned in STAT301. So that template that we're going to use is the third item down under Chapter 9. It says Estimators Workbook Template. I want you to click on Estimators Workbook Template. And open that workbook. So it's an Excel workbook with multiple worksheets, because we're going to estimate all kinds of things, not just the mean, but other things as well. And the tab that I want you on is Z estimate mean. You guys see Z estimate mean? Because that's what we're doing. We're estimating the mean with our good friend the Z curve. Everything in column B that I'm highlighting here, that's input. Everything in column E is output. So basically it just does the formula for me. So let's do the oil change one. You guys find this? It said the mean was 16.9, so I'm going to plug in 16.9. It told me the population standard deviation was 5. I sampled 10, and I wanted a confidence level of 99%. It's not perfectly what we found because it's more precise than what we did actually. But it says 16.9 plus or minus 4.07. We got plus or minus 4.1, I think, which gives us an LCL of 12.83 and a UCL of 20.97. Let's test out both Max and Kira's theories. If I wanted to be more precise, Max told me one thing I could do is lower the confidence level. So let's do that. I'm going to change it from 99 to 90. Does that make it more precise? You bet it does. Now it's plus or minus 2.6. My boss told me, I want you to be more precise, but I don't want you to lose confidence. So I can go from a sample size of 10, let's say I sample 100, and the sample still comes out to be 16.9. Now it's only plus or minus 1.29. I only sampled 100. I didn't do a million. I didn't do hundreds of thousands. I did 100. You could sample 100. Actually, you're going to sample 100 on our final group project. So it's not that hard to do, right? With modern methods. So that's pretty damn good. Now I know I'm 99% confident that the average time it takes someone to change oil is somewhere between 15.6 and 18.2 minutes. Okay. Here's what I'd like you to do. Let's get some real data, okay? Which means I'm going to gather data from you. And we're going to use this resulting data in a lot of different examples. So if you go to chapter 9, at the very bottom, it says Dr. Miko Estimation Survey. You guys see that? Click on that. And this is what we're going to use. We're actually going to use this Google Form tool for our group project. Remember, I kept talking about that. So I'm going to teach you how to use this. And you're going to use the statistical techniques I taught you. But I have a few questions. It shouldn't take you long to fill out the survey. On your favorite social media outlet, how many friends, connections, followers do you have? So whatever that is, I don't know what your favorite one might be, but how many connections do you have with people? How many hours do you study weekly? This is interval data we calculate means from. How many hours did you sleep last night? Did you see the new Star Wars movie? Rogue One. Did you cut a class last semester? That's going to be more, what's that? That's going to be proportional data. If you could have only one of these on campus, which one would you choose? Restaurant, movie theater, bowling alley, or coffee shop? I guess we kind of have a coffee shop. Did you shower this morning? Yeah, you did. You can look like that without showering? It's pretty good. I didn't shower, you guys go, oh, why this homeless man in our classroom right now?
This is
So the responses are starting to come in. And I forgot to clear out last year's data, and I don't think I asked them all the same questions. So you guys started, what the timestamp says, that's today. This was last year's class. And they didn't have all the, I gave you more questions than I gave them. So anyways, are we all done? Yes? Okay. So what I want you to do, and hopefully this works. I'm not sure it's going to work, but I hope it works. So this, what's nice about using Google Forms as compared to paper surveys is it automatically puts the results into a Google Sheet, which is a Google spreadsheet, right? Instead of you having to transcribe it. Yes, that's extra effort. So I want you to, below Dr. Amico estimation surveys, I want you to click on survey responses. So just like I did, there's survey responses. Can you guys do that for me? Does it bring up a Google Sheet for you? These are you. Anonymous Rhino, Anonymous Dingo. Okay. And Google Sheets is okay, but what am I best at? I'm best at Excel. So I want to download this into Excel, and I'm going to show you how to do that, and I want you to do it as well. I want you to go to File, and you see Download As. What's wrong, Stefan? Yours is what?
In Serbian.
Oh, yours is in Serbian? You understand it or no?
You understand the language.
All right. So download as, I don't know. Download as Microsoft Excel. And it should bring your data over into Excel. You guys got that? Yes? Alexis? Yes? Amanda, no? It's not working for you?
Mine's like zipped in or something.
Serbian too? Oh, I see what you're saying. Okay, so did it work, Amanda? No, still? No? I don't know why you zoomed in. Did anyone else get it in Excel? Good. Let's get rid of last year's class. So how would we do that? Let's highlight 2 through, looks like 55, row 55. Right click and then delete. Let's get rid of them. So these are all your responses. Looks like we only have like 22 people in here. Okay, so let's think about it. I want to estimate how many hours did you sleep last night. We tried to do it, I made up numbers, but that wasn't very good. So we now have actual numbers. And let's think about what I need. I need a sample mean. I need a confidence level, which we can get. I need a sample size, which we have. It's what, 22. And we need a population standard deviation. But instead of using the population standard deviation, I'm just going to use the sample standard deviation. So I need to take this column, and I need a mean and a standard deviation and a count. So how can I get those 3 things quickly? Yes. Let's do that. So let's do this. Let's go to data. You guys remember this from last STAT301? Data analysis, descriptive statistics. You guys on that? Click OK. Input range. Let's just do column D at this point. So D1 through D23. Click the close. It's in columns. There are labels in the first row. And I'm going to check summary statistics. And I click OK. And look what it gave me. It gave me a sample mean, gave me a sample standard deviation, and it gave me a count, 22. Those are the 3 things I need. Do you guys remember that? So I'm going to just take this, to make it easy for myself, I'm just going to take this table it gave me, I'm going to copy it. I'm going to go to my estimator workbook. I'm going to paste it there so I have it all in one place, which is nice. Then I'm just going to plug in what it looks for. The mean is 6.1. 6.0, well, it might as well just be more precise. I'm just going to copy it up there. Get exactly it. The standard deviation is 1.04. Let's copy that up. The sample size is 22, and I went 90% confidence. So this is what's beautiful about statistics. Something I had no clue about, like I don't know your sleeping patterns, I don't want to know. But now, just by sampling what took me like a few seconds to sample you guys, 22, only 22 of you, it's not like and I know now with 90% confidence that the average number of hours slept last night by St. Francis University students was somewhere between 5.7 and 6.44 hours, right? If I want to compare, maybe I was doing a study on, maybe I'd ask you this question on like Saturday morning, you probably sleep a lot more. You guys probably sleep in Saturdays, right? Typically, some of your athletes. But I'm guessing that number would go up, right? No, yes. I mean, my 17-year-old, he can sleep like 12 hours. He's exceptional. The sleeping ability. You can shower for like 30 minutes too. That's another dad pet peeve. But you see how when you have no information, you can quickly get a lot of information about things that think about in the business world. Like this is kind of neat to learn how long people sleep. But if you think about the business world, you're trying to go into a product. How much people do they spend on, I don't know, this line of products? I don't know, beauty care. How much does this demographic spend? So now we know how big the market share is. And is it worth going into this market? There's a lot of analysis. A lot of times in the business world, for us to make a decision, there's things we don't know. And this can help us know them, right? This can help us inform our decision and make better decisions. And hopefully make things work well for our organization or our own company. So, does this make sense? You guys understand this? So how about this for homework? In that spreadsheet, in that Google sheet, why don't you guys, that we downloaded to Excel already, why don't you guys estimate how many connections people have on average? And when you come back into this, there might be more people. There might be the 11 o'clock class. So do an estimate of this, how many social connections. 1,265. And how many hours spent studying a week? 1. That's a little. So do an estimate of those things with Excel. And then by hand, I would like you to do, in that PDF, that PDF that we were using at the top, I would like you to do, let me see, I'm going to probably make this less. I have 9, 11, 22, 23. Just do 2 of those. How about that? I'll just make it easy. And I think we did one of them already. We did 23. So do 2 of these. And then don't worry about part 2 because that was an old one. Just use that spreadsheet that survey we just came up with. Randy. Yeah, I'll show you how to turn it on. Questions? All right. Have a great weekend, and I will see you Tuesday. Okay, I'll put you in.
What I was, but I looked